Alright folks, it's Mr. Widmeyer here, going to be recording for you for class today. Well, actually tomorrow for me, but today for you since you're seeing it on the day that you're supposed to see it and I'm recording it the day before, so that way it's ready for you. Everyone confused? Great. Alright, here we go. So, we're going to start on page 447 in your books, so if you could open those up, the new books I passed out yesterday to you. Again, page 447, we're going to talk about the properties of rectangles, rhombuses, and squares today. Alright, so again, page 447, here we go. So the top of the paper here says the essential question that we want to be able to answer is, what are the properties of rectangles, rhombuses, and squares? Alright, so you guys have heard of these shapes before, or at least most of them, hopefully. And so this should be pretty straightforward, right? So we know a rectangle is a quadrilateral with 4 right angles. Another way we could say that is it's a quadrilateral that is equiangular, right? All 4 angles are the same, all 90 degrees. So there's a rectangle. Alright, we're going to skip the little explore here since I'm not there to kind of work on that, and we're just going to jump right into these properties. So turn the page there. And at the top of page 448, you see our first kind of set of properties of rectangles. So, if a quadrilateral is a rectangle, then it's also a parallelogram. Well, that's kind of like duh. So a rectangle is like a special type of parallelogram. But then, if a parallelogram is a rectangle, its diagonals are congruent. So a rectangle has congruent diagonals. And again, you can kind of just see that in the picture. If you look right here at rectangle ABCD, you can kind of just like, oh yeah, it's very obvious that the diagonals are congruent. Now, that's not the only property for rectangles, right? Since a rectangle is also a parallelogram, it also has all the properties of parallelograms that we've talked about, okay? So, for example, parallelograms have opposite sides congruent. Well, same thing is true for rectangles. Opposite sides are congruent in a rectangle. Also, opposite angles are congruent in a parallelogram, and just so in a rectangle as well. So opposite angles are congruent here, opposite angles are congruent here as well. And then one more thing, the diagonals in a parallelogram bisect each other. So not only are the diagonals equal because it's a rectangle, but also since a rectangle is a parallelogram, the diagonals bisect each other. So AC is bisected by DB and vice versa. Okay? We're not going to go through the proof or anything like that. I just wanted to go right into the properties there for you. All right, we're going to kind of speed through that a little bit. But we do have some examples here of how we're going to apply that. So for example, in the your turn here, it says to find each measure. So for example, AD is listed here as being 7.5 centimeters. So we'll label that there, 7.5 centimeters. And then DC is 10 centimeters. And we're asked to find the measure of DB. So how can we do that? Well, since this is a rectangle, this side will also be 7.5 centimeters. And then with that measure, that means that DB, if you look here, we have a right triangle. And so what can we use to find the third side of a right triangle? And if you said Pythagorean theorem, you're right. So we could say 10 squared plus 7.5 squared equals our c squared there. All right, and then we can kind of do the math there. So we get 100 from that, and then 7.5 squared is 56.25. And so then we get c squared equals 156.25. We can square root both sides, and we get c is 12.5. Actually, that worked out very nice. How about that? Okay. And so our diagonal there, DB, is going to be 12.5. All right. And then we can do a similar method there for the number 6. It's just different measurements, that's all, but it's still using Pythagorean theorem. All right. By the way, since DB is 12.5, what does that mean AC has to be? Well, again, if we use the properties from rectangles, we know that the rectangle's diagonals are congruent. Okay, since this is a rectangle, right, all the angles are equal, and so the diagonals will be congruent. So if DB is 12.5, AC will also be 12.5. And that's the only extra property that a rectangle has, is that its diagonals are congruent. So it's got all the parallelogram properties plus the diagonals in a rectangle are congruent. And again, you can kind of see that. All right. Next here we have the rhombus. Okay, the rhombus is a little bit special. All right, some people might look at this and call that a diamond. A diamond is actually not a geometric term. Okay, we've talked about that. You use it in common language, I guess, and stuff, and it shows up in like cards and things like that. But diamond is not a geometric shape. Rhombus is. Okay, and so a rhombus is a quadrilateral with 4 congruent sides. So 4 congruent sides, that means it's also equilateral. So you could also say it's an equilateral quadrilateral. Get a little rhyme going there. The properties of a quadrilateral, so a rhombus is also a quadrilateral, and it's also a parallelogram. Okay, so since a rhombus is a parallelogram, that means it has all the properties of a parallelogram, plus the diagonals of a rhombus are perpendicular, and the diagonals bisect a pair of opposite angles. So each diagonal bisects the angle that it goes through. So if you look here for an example at this rhombus JKLM, we have a diagonal here, JL, and a diagonal here, MK. MK bisects angle M and angle K, cuts it into 2 equal angles here. Same thing with JL, it bisects angle J and angle L into 2 congruent angles. And so that's another property we can kind of utilize there. And again, you can kind of see that in the picture here. Whereas if we look over here at the rectangle, it's pretty clear that this diagonal does not bisect angle A or angle C, right? It's not quite even. Same thing with angle D and angle B, okay? But a rhombus, its diagonals do bisect their angles that they go through, and the diagonals are perpendicular. And again, you can kind of see that there too. The diagonals are perpendicular. They make like a right angle. All right, so we'll turn the page here, and we'll use some properties that we've got. All right, so in this picture, we're asked to use the rhombus VWXY to find each measure. So there, we're asked in letter A to find the measure XY. So we want to find this measure right here. Well, since this is a rhombus, how are all the sides related? Well, if we go back to our definition of a rhombus on the previous page, a rhombus is an equilateral quadrilateral. That means all the sides are congruent. We're told this shape is a rhombus, so we can use the definition of a rhombus, that all the sides are congruent. Well, XY, we don't have any information about. But we are told that VW is 6m minus 12, and WX is 4m plus 4. Since this is a rhombus, 6m minus 12 has to equal 4m plus 4. And then it's just a matter of solving that equation. So we can subtract 4m from both sides. We get 2m minus 12 equals 4. We can add 12 to each side. We get 2m equals 16. And then divide both sides by 2, m is 8. So the final answer is 8, right? No, it's not. M equals 8 is not our solution. It's part of our solution. We want to find xy. And so this is not our final answer. We want to figure out what xy is. And so for that, we can either plug in the m for wx or for vw. We're going to get the same answer either way. I'm going to plug it in for wx. So I'm going to do 4 times 8 plus 4. 4 times 8 is 32, plus 4 is 36. So xy is 36 units long. Okay? Next here, we want to find the angle YVW. Okay? So YVW is this big angle right here. It's basically all angle V. It's the full angle V there. We're not told anything about this angle V. We're told that XVW, this angle right here, is 9n plus 4 degrees, and that's it. Now we do know that the diagonals of a rhombus, they cut the angles into 2 equal parts. They bisect the angle. So for example here, this diagonal VX bisects the big angle V here into 2 smaller angles. So if 9n plus 4 is this small angle, this angle also is going to be 9n plus 4 degrees. But that doesn't really help because we don't know what n is. And if we add these two things together to get the big angle, YVW, that we're interested in, it still doesn't help because, again, we don't know what n is. We could set 9n plus 4 equal to 9n plus 4, but if we solve that equation, we're going to get 0 equals 0. And again, we don't know what n is. There's only one other place where we're told what n is, or we have a relationship with n, and there is something there with n in it. 3n squared minus 0.75 is this angle right here. Now, we don't know what this angle is. Or do we? Right? We can't say that 3n squared minus 0.75. There's no easy way to relate that to this 9n plus 4 over here. So we can't really set up an equation that way. But what's one of the properties of the diagonals of a rhombus? The diagonals of a rhombus are perpendicular to each other. That means they make a 90-degree angle. So this angle right here is a right angle. And again, if you kind of look at it, you're like, oh yeah, that does look like a right angle. So we can take that 3n squared minus 0.75 and set it equal to 90. Okay, we'll add the 0.75 to both sides, and we get 3n squared equals 90.75. Kind of a weird number there. Divide both sides by 3, we get n squared equals 30.25, and then we'll square root both sides, and n is equal to, I'm going to get my calculator out for this, 5.5. Now again, we're not done yet, right? Because we're not interested in what n is. We want to know what yVW is. Well, since yVW is made up of these two angles, it's going to be equal to 2 times that 9n plus 4. And of course, that's 2 times 9 times the 5.5 plus 4. You can type that whole mess into your calculator, 2 parentheses, 9 times 5.5 plus 4. We get 107. So yVW is equal to 107 degrees. All right. So again, the property there that we were using, we wanted to find yVW. So we had to use both of the kind of diagonal properties of the rhombus. The rhombus, its diagonals bisect one of the angle. Okay, so this diagonal here, Vx, bisects both angle V and angle X in the rhombus. So that means this part is equal to this part. That's how we knew that 9n plus 4 was both parts there. And also the diagonals intersect at a right angle. They're perpendicular to each other. So that's why that 3n squared minus 0.75 equaled 90 degrees. We could solve for the n for this problem to then use the n in these two right there and get our answer. Okay? So that's the idea. The next properties we're going to look at, finally, is for the square. And the square is basically a quadrilateral that is both a rectangle and a rhombus. If you look at it, the definition is a square is a quadrilateral with 4 sides congruent and 4 right angles. That means it's both equilateral and equiangular, and we know that means we call it regular. A square is a regular quadrilateral. Okay? So, that means that because a square is a rhombus and a rectangle, it's also, therefore, a parallelogram. So that means it has all the properties of parallelogram, rectangle, and rhombus. So since it's a parallelogram, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. Okay? Since it's and opposite sides are parallel too. Both pairs of opposite sides are parallel. That's because it's a parallelogram. Because it's a square, because it's a rectangle, all the angles are congruent and the diagonals are congruent. And because it's a rhombus, the diagonals bisect each other and the diagonals bisect the opposite angles there too. And also all the sides are congruent because it's a rhombus as well. So it's got all the properties of every shape, every one of those quadrilaterals we talked about. Okay? We won't worry too much about going through those explanations and stuff, but here is a really nice chart to kind of show where all of these different quadrilaterals kind of fit. So we have the big box here that says this is for all the quadrilaterals there are. Inside the box of quadrilaterals, so there's other things that are not parallelograms that are still quadrilaterals, right? But inside that, we have the parallelogram kind of oval. And then within the parallelogram, we have the rectangle oval and the rhombus oval. So rectangles and rhombuses are inside the parallelogram oval, so therefore they're always a parallelogram. Okay? But then where the rectangles and the rhombuses overlap, that makes a square. And since the square is inside the parallelogram, it's also a parallelogram too. So it's kind of a nice little Venn diagram there to show, if a quadrilateral is a square, it's also a rectangle, a rhombus, and a parallelogram. Okay? If something is a rhombus, that means it's also a parallelogram, and it could be also a square depending on other properties. Okay? Stuff like that. All right, and that's that. We'll get to the assignment there in just a second. I want to have you guys flip though to the next section because we're also going to look at then conditions to make a rectangle, a rhombus, or a square. So flip to page 461. Page 461. This is the next section. Okay, so flip to page 461 there. Okay, so on page 461 you can look at properties that we can use to show that a shape is a rectangle. So, conditions for rectangles, right? Just basically it's using the properties. So, if one angle of a parallelogram is a right angle, then that parallelogram is a rectangle. Okay, so if we can just show that one angle of a parallelogram is a right angle, well then, because of the properties of parallelograms, right, opposite angles are going to be congruent, so this angle will be a right angle, and then this will be a right angle as well because these are going to be supplementary and these will be supplementary, okay, because they're co-interior or same-side interior angles and they're supplementary because of the parallel lines. So, having one right angle in a parallelogram makes it a rectangle. Likewise, having congruent diagonals in a parallelogram guarantees that you have a rectangle as well. So that's like the property of a rectangle, right? Its diagonals are congruent. So if you have a parallelogram with congruent diagonals, then it's a rectangle. All right? So it's just using those properties kind of in reverse. So let's take a look at this your turn here on the next page. It says, use the given information to determine whether the quadrilateral is necessarily a rectangle. Explain your reasoning. All right, so in the first case here, for number 4, we're given the information that EF is congruent to GH, and FG is congruent to HE, and then FH is congruent to GE. So let's start with these two pieces of information here. FE is congruent to GF, FE is congruent to GF, and EF is congruent to GF, and FG is congruent to HE, and FH is congruent to GE. All right, so if we look here at those two, at those markings, I guess I'll say, all right, we can see that now we have the two diagonals congruent. But is it enough with the information that we're given there to say that these two shapes are in fact congruent? Well, we know the diagonals of that quadrilateral are congruent. Does that make it a rectangle? Okay. I think EFG. All right, I think there is a typo in the book here. I think what they meant to say here for the GF is that this is supposed to be, EF is congruent to GH. So that's supposed to be congruent, and then these two are supposed to be congruent. Okay, I think that's what's going on here, because otherwise this would not work. And I'm looking at the book answer key right here, and it's saying that yes, the shape is a parallelogram. So I think there's a typo. This should be GH here, not GF. With that being the case, we have opposite sides congruent, therefore making this shape a parallelogram. And then we have the further condition that the diagonals are congruent, and so therefore it's a rectangle. So it is a rectangle because, I'm going to abbreviate here, opposite sides are congruent and diagonals are congruent. All right. Now, if we look at number 5, we kind of have to reset here. So we ignore all this other information on here. So I should probably scribble this out. Now we're told that given that the measure of angle FEG is 45 degrees, so FEG is 45 degrees, and GEH is 50 degrees. Does that give us enough information? With only that, is that enough information to say that this quadrilateral is a rectangle? Well, if FEG is 45 and this angle here is 50 degrees, that means this full angle here, FEH, is what kind of angle? Well, 45 plus 50 is 95 degrees. Can a rectangle have a 95 degree angle? And the answer is no. It is not a rectangle. Okay? Because measure of angle FEH is equal to 45 plus 50, which is 95 degrees. So it's not a rectangle given that information. Okay? So that's how you kind of use the properties of a rectangle to then show that something is a rectangle. You first need to establish it's a parallelogram, and then you can use the properties of the rectangle to further establish it's a rectangle. The same is true for rhombuses. We start out, we want to first show that that the quadrilateral is a parallelogram, and then use the properties of a rhombus to further specify it's a rhombus. So, for example, if we have one pair of consecutive sides, consecutive meaning like the ones next to each other, right? If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Why is that so? Why do we only need two? Well, because if this shape's already a parallelogram to start, if we say that this and this side are congruent, by the property of parallelograms, opposite sides will be congruent as well, and so it makes it a rhombus because then all four sides will be congruent. Okay? Another property of rhombuses, right, is that the diagonals of the rhombus will be perpendicular. So if we have a parallelogram whose diagonals are perpendicular, that parallelogram then is a rhombus. And likewise, if we have the diagonal of a parallelogram that bisects a pair of opposite angles, then again, we know that parallelogram is a rhombus. So again, establishing a parallelogram first and then using any one of these properties helps us show that we have a parallelogram in fact. Okay? So, looking at the next page here on page 464, we're going to apply these conditions. So we want to determine, for example, if the conclusion is valid. If not, tell what additional information is needed to make it valid. So in letter A, we're given that AB is congruent to CD. So AB is congruent to CD. I'll go ahead and mark this in. BC is congruent to DA. AD is perpendicular to DC. So AD perpendicular to DC. And then AC is perpendicular to BD. Okay? So, because we have opposite sides congruent, what does that make this shape? Automatically, it's a parallelogram. But what other properties do we have here? Well, AD is perpendicular to DC. Since we already have this shape as a parallelogram and we have one 90-degree angle, that means it's really a rectangle. But since the diagonals of that parallelogram are also perpendicular, that means it's also a rhombus. So if a quadrilateral is both a rectangle and a rhombus, then more specifically, it is in fact a square. Okay? Now if we look at the next piece of information here, for letter B, we're told only that AB is congruent to BC. So AB is congruent to BC. We forget this, we forget this, we forget that, we forget that. All we're told is that AB is congruent to BC. Now you might say to me, well, Mr. Whitmire, that makes it a rhombus, right? Because if I go back to my properties here, Mr. Whitmire, you said if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. And look at that. I see right there one pair of consecutive congruent sides. Right there and there. They're both congruent, so this makes this a rhombus. And you would be right if it weren't for this little pesky word here. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. The problem is, with the information we're given here, we can't say that ABCD is a parallelogram. We don't have enough information to say that. In the previous problem, we were told that AB and CD were congruent and AD and BC were congruent. We had opposite sides, both pairs of opposite sides congruent, making a parallelogram. Here, we're not told that. All we're told is that AB is congruent to BC. And that's not enough to say it's a parallelogram, and so if we can't say it's a parallelogram, we can't then also say it's a rhombus. don't have enough information. Okay, so this conclusion is not valid. We would need to know that this shape is a parallelogram first, and then we would know that that is in fact a rhombus. Okay? And then that pretty much covers it. So you guys are going to use those properties to help you identify what kind of special parallelograms and quadrilaterals that you have. All right? So for your assignment, I believe that the substitute should have that for you, so he'll go ahead and write that up now. You have the rest of class to work on your assignment, and then also don't forget to work on your assignment from yesterday, too, if you didn't quite get that finished. I hope you'll have a great day, and I will see you tomorrow. Bye.